In Lesson 9.5, you'll solve problems involving direct variations. When the ratio of two variable quantities is constant, the relationship is called a direct variation. The constant ratio is called the constant of variation. It's also a proportional relationship, which is what we talked about earlier in this course. Example 1 says, find a constant ratio. The amount of money Robin has raised for a bike-a-thon is shown in the graph at the right. Determine the amount that Robin raises for each mile that she rides. So let's go ahead and say $15 for 2 miles, $30 for 4 miles, and $45 for 6 miles. If you take and divide each one of these ratios, you're going to get $7.50 per mile. Since these ratios are all equivalent, it's a direct variation, otherwise known as a proportional relationship. A direct variation looks like this as an equation. Y equals kx. And as a graph, it's going to be a straight line that goes through the origin, through the point 0, 0, just like a proportional relationship does. Example 2 says, refer to the information at the left. Assume that the age of a dog varies directly as its equivalent age in human years. What is the human year age of a dog that is 6 years old? Well, over here it says a 3-year-old dog is often considered to be a 21 in human years. So if the age of a dog varies directly as its equivalent age in human years, it's going to be in this form, y equals kx. And they tell you to have x be the dog's actual age and y be the human equivalent age. So a dog that is 3 years old, so I'm going to put a 3 for x, times some constant of variation is going to equal its human equivalent age, which is 21. Now when you solve this equation for k, you end up dividing both sides by 3, and you end up with k equals 7. Now that you have k equaling 7, you're going to take that and you're going to plug it in place of k to have your equation. So y equals 7x. Now if we want to figure out what is the human year age of a dog that's 6 years old, I'm going to plug in 6 for the dog's actual age. So y, or the human equivalent age, is equal to 7 times 6, which is 42 years. You may want to pause the video and try the next one on your own. The grocery store sells 6 oranges for $2. How much would it cost to buy 10 oranges? Round to the nearest cent if necessary. What you could do with this is use the direct variation equation of y equals kx, where x represents the number of oranges and y being the total cost. So $2 for 6 oranges, so k times 6. Divide both sides by 6. K is going to equal 1/3. So that means my equation is y equals 1/3 x. And now I could plug in for 10 oranges, I could say y equals 1/3 times 10. 1/3 times 10 is 10/3. 10/3 is 10 divided by 3. 10 divided by 3 is 3.3 repeating. And since we're talking money, we would want 2 numbers after the decimal. The third number after the decimal is a 3, so we round down to $3.33. Now, personally, I would prefer just to write a proportion for this problem. I would say 6 oranges for $2 equals 10 oranges for X dollars. And I would say 6 times X is 6X equals 2 times 10, which is 20, and divide both sides by 6. 20 divided by 6 equals $3.33. In the next example, it says determine whether each linear function is a direct variation. If so, state the constant of variation. Well, if it's a direct variation, the ratio of y to x is going to be constant. So we'd want to compare these ratios. 1 over 25 2 over 50, 3 over 75, and 4 over 100. You can compare them by changing them all to decimals if you wanted. If you made these all decimals, you would just do a division problem, 1 divided by 25, 2 divided by 50, 3 divided by 75, and so on. Or you could just take each one of the fractions and simplify them, and when they're in simplest form, if they're the same, then it's going to be a direct variation. 1 divided by 25 is 0.04. 2 divided by 50 is also 0.04. 3 divided by 75 is 0.04. And 4 divided by 100 is 0.04. So this one is, yes, it's a direct variation. And the constant of variation is either 0.04 or 1/25th, depending on if you write it as a decimal or a fraction. In this next example, 36 over 2, 52 over 4, 68 over 6, and 84 over 8. Again, we're just comparing the y to the x. So 36 divided by 2, that's going to be 18, or $18 per hour. 52 divided by 4, that's $13 per hour. So I can already tell this is not going to be a direct variation because the earnings per hour is not going to be constant. 68 divided by 6 is 11.3 repeating, and 84 divided by 8 is 10.5. So this one is not a direct variation because the ratio comparing y to x is not constant. I'm going to just leave you here with this table of proportional linear functions versus non-proportional. Proportional linear functions are in the form y equals kx, and it's a straight line that always goes through 0, 0. A non-proportional linear function is in the form y equals 2x minus 1, meaning there's something else done to it. It's either going to have something added to it or subtracted from it, which is going to make it move away from the origin. A non-proportional linear function does not go through 0, 0. A proportional linear function does go through 0, 0. That's going to be important to you going forward.